Hello everyone, my name is Michael Croxton and I'm with Canon Virginia Incorporated. I'm here to introduce you to the Canon Shuttle Mold System. First, a little bit about myself. I've been in the industry for over 30 years, which isn't much considering this gentleman standing next to me, but I have been involved with most components of injection molding to include production, engineering, and tool manufacturing.
Good morning, everyone. My name is Dale Bartholomew. I'm the technical manager for Japan Steelworks America, and we supply the injection molding machine here in partnership with Canon. And I've been in the injection molding industry for over 40 years. I started out troubleshooting and repairing injection molding machinery with my father's company, and I've been doing it ever since. And I've worked with several injection molding machine manufacturers throughout the years. We've partnered up with Canon here with the Shuttle Mold System and working with Michael and getting this going, and we're here to do your presentation on the Shuttle Mold System.
Thank you, Dale. So what is shuttle mold? Here's a simple way to describe it. 1, 2, free. One machine, 2 molds, 1 free process. I would like to say 1 free part, but we still have material costs. Shuttle mold is a system that shuttle molds in and out of an injection machine during production. The goal is to keep the machine running during the entire cycle. We use one part's cooling time to mold another part in a separate mold. It's a shift in thinking. We spend so much time trying to reduce cycle time and not enough how to use it for our benefit. Sorry about that. From this very simple concept of shuttling molds, we're able to increase machine capacity and productivity, and in some cases, this can double. A typical molding machine consists of mold close, injection, pack, hold, cooling, mold open, part ejection. And during the cooling stage, the only thing the machine is doing is recovering the screw. The rest of the time is just sitting idle. And as we all know in manufacturing, sitting idle costs money. The shuttle system utilizes this idle time to mold another part in another mold. We do this by allowing cooling to occur outside of the press. I'll run through the basic sequence. Mold A is currently in the machine. Injection, pack, hold, and once hold is done, mold A is shuttled out of the machine and mold B is shuttled in. During the shuttle process, the screw recovers for the next shot. Once mold B is shuttled into the press, injection, pack, and hold. Once hold is done, mold B is shuttled out and mold A is shuttled back into the press. Now with the part in mold A cured, the mold opens, parts ejected, mold closed, injection, pack, hold, and the process is repeated. Depending on your process, the shuttle mold system can increase your machine capacity or productivity by 50%. If you're running cycles just above 25 seconds, you will see an improvement in productivity with your machine. I will encourage you to stop by and see me after this presentation, and we'll work through your process parameters and see how the shuttle system can improve your efficiency.
Thanks, Mike. One of the ways that this came about was a couple years back, a couple of K shows over in Germany. We had this machine running. We were producing just this cup. But at that time, we were given a directive from Japan to focus on green technologies, and we were running some PLA material. And the PLA material requires a lot of holding time. And with those long holding times, there's also a long cooling time. So the cycle on that part was well over 90 seconds. And the problem with that is we were just running that one part, we were running the one cup. It was this exact mold. And, you know, people would come by. It's an all-electric machine, so it's very quiet as it is. And during the cooling, you know, the injection phase, the long hold phase, and the cooling phase, the machine's just sitting there, and it looked like it was broke. It was sitting there doing nothing. It was quiet, so people would just walk away. They didn't think it was in production. So I explained this to one of our directors when I got back, and he knew of the Canon shuttle system, and he knew of one of the directors over in Canon. So they started talking, and they came up with this concept, and it was a perfect application for it. So we built the other tool, the other saucer mold, and now we've got the saucer mold in conjunction with the shuttle system, and it works out perfect. We cool one section outside of the machine while the other section is in there producing.
So behind me, you can see the system in operation. We are producing the cup and saucer. In a standard process, we run these molds at 80 seconds with this material. With the shuttle system running both molds, we're now running 2 molds in 80 seconds. So typically a 4-cavity mold running in a standard process, running at 80 seconds will give you 180 parts an hour. But because we're running 2 molds, we're producing 360 parts an hour. Think how this can affect your machine capacity in your shop. How many of you don't have enough room for additional machines or have the budget to buy additional machines? The shuttle system can actually double your productivity in machine capacity. It's the BOGO of injection molding. So the average cooling time for these 2 molds is 55 seconds. This gives us enough time to shuttle molds in and out of the press. And in this scenario, we're able to double our production rate and productivity by 50%. 50%. When I was supporting production, I was constantly being challenged to decrease process costs by 5%. And we're able to do this by 50% now. Since we're utilizing 1 injection unit, we're limited to 1 melt temperature and 1 material. However, we're able to run 2 process conditions with the help of JSW because they have programmed this machine to recover the screw for the next shot, which allows us to run 2 different shot sizes. When 1 mold is shuttled out of the press, the screw recovers for the second mold, allowing us to run 2 different shot sizes and 2 different injection profiles. So we developed this simple calculator to help you see how the shuttle system can reduce your process costs. You input the machine rate, cycle time, cavitation, changeover time, production volume, and the number of changeover times, and the calculator quickly outputs your potential savings in process, your changeover time, and your increases in productivity. Please come and visit us at the booth, and I can walk you through this calculation process. I invite everyone to come and take a closer look at the system, and I welcome all questions you may have. Again, my name is Michael Croxton, and I thank you for your time today.
Another thing is, real quick on the material on this is post-consumer resin, and this is FDA approved, so you can drink out of these cups. You don't have to worry about cooties or anything. So that'll put your mind at ease. And it is all regrind material. It is post-consumer reprocessed, so it's environmentally friendly. And we appreciate you stopping by. Again, my name is Dale Bartholomew with Japan Steelworks. Feel free to come by with any questions you have on anything. Enjoy the rest of your show. Thank you for your time.